So today is the fifth session of this series, and the title of today's session is Symptoms of AI Bias in Our Day-to-Day Life, which is such a fascinating and timely topic. I think we can all agree on that. Our facilitator today is the wonderful Rahaf Albalkhi, and I'll tell you a little bit more about Rahaf before handing over. So Rahaf is the founder, a responsible AI consultant, and a member of the Ethical Intelligence Experts Network. Her work focuses on operationalizing responsible AI, specifically unbiased AI, across many industries. Rahaf holds a master's degree in electrical engineering from the University of Victoria, with her thesis focused on designing an acoustic modeling technique that is unbiased against people with speech disorders. Rahaf, it is such a pleasure and an honor to have you here with all of us today. Thank you so much for sharing your time, your expertise, and your experience with all of us. Valentina and I had the opportunity to have a peek at the presentation already, which looks fantastic and super engaging. So thank you so much for being here, and over to you.
Well, thank you so much, Julia. It is a pleasure for me to be with all of you here today. I was super excited while I was preparing for this talk today because it was something very close to my heart to do something for a Victoria company. So this is awesome, especially BC Transit. As a writer, it was like, interesting topic. So I will start by presenting the slides. I would like first to start by acknowledging the land where I'm working from and joining you today. I acknowledge and respect the Lekwanga-speaking peoples on whose traditional territories I live and work, and the Songhees, Esquimalt, and Wasanich people whose historical relationships with the land continues to this day. As Julia mentioned, today's topic is going to be on symptoms of AI bias in our day-to-day life. That means the focus today is going to be on you as an individual. Now, we all know, or perhaps you heard about the AI bias in terms of it's denying loans for certain categories of people based on their group membership of certain ethnicity, or denial of hiring in these systems. Now, this is something that is very big right now. But today we're not going to focus on that fairness. We're going to focus on these daily interactions that we have with bias systems and how that affects us without us really framing it as a bigger problem, such as denial of loans, for example. So this is the topic today. Our goal is to understand AI bias, and then so that we can make informed decisions of how we interact with these systems. Let's go to next slide. Okay, so to get started, I want to first ask you to help me figure out a name for this fictional character. Please type it in the chat. Think about a name. It is 1973. He's an average person. He is having coffee, listening to the radio, getting ready for work, and he's 26 years old. What would you like to name him? It doesn't have to be like a real name even. Just give me any name in the chat. Sam. Oh, Simon. Okay, we'll go with Sam. That was the quickest. Stu, Bob. Okay. We're just going to go with Sam because that was the fastest. So here we go. We have Sam. Now, he is, as he's preparing for work, he's imagining 2025. What do you think he had in mind? Flying cars. Okay. So just to give you a little bit of context, in 1973, there was the first debate where people were either talking that AI is a thing or is it a mirage? That was the time where the first debate happened. So, okay, flying cars, that's possible. Living on the moon, I love that. Retirement, that's very accurate. Green Day, HAL 9000, I'm not sure what that is. Robots, that's true. Robots have replaced the humans. Okay, I can see that because in 1949, I think, when he was born. Was it 49 or 48? It was the time where like a famous writer was talking about robots that they will take over. Robots that makes dinner, space travel. Okay, I love all of this. That is true. I would also imagine space travel. That's cool. Okay, now fast forward to today. No wars. Okay, fast forward to today. We have systems that assist us daily. This is the reality now, not imagining. Great systems that make the impossible possible. They're designed poorly, though. The decisions it makes does not represent me. The photos it generates reinforces my exclusion from the society. The answers it gives me makes me doubt my abilities. We are not noticing how our identity is slowly vanishing into the shadow of an AI system. The world did not end, the machines did not take over, but we are slowly giving up on being us. We don't think anymore what we want for these systems to be. We think out of fear about what the future will be forced on us to live in. And today we're going to change this narrative for whatever we have today. Okay, to get started on that, we will start with a brief introduction on AI systems. This is not going to be technical, it's going to be high level because we want to understand how these outputs are reached for a system. Now, there are two approaches or like paradigms for intelligence, the human intelligence that have been translated into artificial intelligence. That is symbolic AI and neural AI. Symbolic AI, think of this as like the simple recipe that you find in your cookbook. This is the good old-fashioned AI. The mechanism behind symbolic AI that it is based on reasoning, it uses logic, and the system follows a set of rules. So right here, I have an example for a simple game where you need to collect coins, avoid obstacles in the game. If you hit an obstacle, you start all over, or if not, and you reach the end, like you get to win. This is just the simple mechanism behind how symbolic AI works. Now, the distinctive thing about symbolic AI is that it doesn't require a huge amount of data. You just need data enough to make conclusions about these rules that you want to create, and then also some data to keep updating the system. So that's the learning part. It's explainable. So basically, if you win, you know why you won. Like there are steps that you can trace back to understand why you won or why you didn't win. And it requires limited compute power if we're talking about a small system, but it needs a long time. An example of this, and this is something that we're still using symbolic AI for till this day, because it's a very hard problem to solve with the neural AI, and that is weather predictions. On a national level, we're still using models that are heavily based on physics to understand the weather, and it takes days to come up with the predictions that are usually not always very true. Now, recently there have been advancements with neural AI, but on a national level, to my understanding, we're still using symbolic models. So that is a real example of symbolic AI and how we're still using it today. The next one is neural AI. The mechanism of neural AI is based on the concept of learning. So it is biologically inspired. Think of this as the experiences that you go through. So it's trying to mimic how your neurons connect to each other in order to make a conclusion at the end or make an output for you to use in your real life. So basically, this depends on getting to be exposed to a lot of data, not only one experience, not only one situation that you go through, but you need to get to be exposed to multiple situations that are similar to each other. You learn from that difference, and then you make a conclusion at the end. This is exactly what neural AI is trying to mimic, is to see how these neurons are connecting to the other neurons. So think of this as the input layer, which is this first layer, can represent features that you own. Such, for example, my name is Rahaf, so that's my name, my age, the country of origin, and these will be like, each one of these features will be one of these neurons, let's say. And then the system will try to learn the optimal path. And these, like, think of any of these arrows as mathematical operations. So basically, it will try to figure out the best path that it will go through multiple of layers. I'm not talking about millions. I'm not talking about billions. I'm talking about like a trillion something parameters, not layers really, but parameters in order to get the right calculations to get from one certain input to a certain output. So it basically, from my own features, it will learn a path. From Julia's features, it will learn a different path that it will be thinking, okay, I need to optimize this. I need to change the mathematical operations that I did at the beginning so that I can make this output similar. So basically, if we think about neural networks in this sense, if it learns from different examples, that means the more people that are like me, I have a better chance to be represented in the outputs of the system. It works for the average person. However, there's something that we need to keep in mind that there's only one Rahaf, there's only one Julia, there's only one Carly, only one Valentina, and that is really because we're unique individuals. So we cannot say that there is any neural network in the world that works specifically for our unique identities. It works for the general features that we have, and other people share it with us. And that's pretty good. Like, we have noticed that systems have been doing really good on that level in late advancements such as ChatGPT. So the mechanism behind it is that it gets an output, it processes it, and then it gives us an output. It's a set of neurons, layers, and connections between these neurons. Distinctive features that it is data hungry. It needs a lot of data so that it can scale and it make a general assumption about the data that it is being fed. It is black box because we're talking about trillions of parameters. You can't really trace back why you got an output all the way back to which input really triggered that kind of output. It is of a black box nature. It needs a huge computational power and cooling needs. It is something that I'm not sure if you're following with the news right now, but there's like companies are racing to build the bigger data centers and trying to figure out these problems around cooling needs. However, it is fast and it works for the general population, so it is something that actually works in our days. Now, examples of these are natural language processing applications, computer vision applications, and more. Really, neural network, you can use it with multiple stuff. Another thing that I want to your help with the chat is generative AI. Now, generative AI, what do you think is based on? Do you think it's based on the symbolic diagram, symbolic approach, or the neural approach? Neural. Okay, that is right. Right now, it is based on neural AI. Now, with Gen AI, I mean things like Sora, Claude. However, it can be done in symbolic too. So think of these very old chatbots that now we get frustrated dealing with on some websites that they're still using their chatbots of like reply with Y to accept or reply stop to stop these messages. Now, these generative AI things that are based on symbolic. Okay, so that's with generative AI. So now we talked about intelligence approaches that we have translated into AI. Now, I don't want to limit us to thinking that this is the way that the human intelligence works. It's not only two approaches. There's like a ton of different theories on how intelligence works, but these are the two approaches that we translated to systems. Okay, so if we take one approach and then we want to put it in an AI system, there's a very important component that comes to play, which is the human. So you get the system. There are two parts inside that system, which is the data that you feed into the system as an input, and then the whole processing and output thing. And then the third component of an AI system is the human. And I'm talking about AI systems that as something that is deployed in real life. So basically, the system impacts the human, whether with its decisions or whatever, and then the human gives feedback loop to the system. Now, the human, I want you to think more than us as users. I want you to think about regulators who are setting regulations for how these systems should work. I want you to think about the developer who is developing those systems, and they are feeding back all of their ideas and imagination for how these systems should look like. The funder who is funding the whole R&D process for this system, and what are their goals that they want to optimize the system for. So this is a system as a whole. It's not only the data and the computational process, but the human as well. So now we figured out what AI systems are. I would like to start now by talking about AI bias. How does it happen? What it is actually in the first place, how does it happen, and what it means to interact with these biased systems. So let's get started. First, now to explain what bias is, I can't really do that in separation from first also explaining what unfairness is and what discrimination is. So we have bias is actually think of bias as an inclination towards something. So if we all own our different sorts of biases. So for example, I like chocolate ice cream. That is a kind of bias that actually identifies me. So bias doesn't have a good or a bad label. It's not something that you can identify as good or bad. It's more of something that you can identify as something you want or you don't want. So wanted and unwanted. So bias in simple terms, it's just, yeah, in case you want to zoom in, that's great. So bias in terms of just the basically in natural language, it's an inclination towards something. And then in technical terms, it's a deviation from a statistical standard for those of you who are with a tech background. It's a deviation from a statistical standard, and that standard is something that you identify at the beginning before you start building your system. Now, let's put that kind of bias in a social context where you are, for example, giving loans or providing services to writers, and then you deny a service to one of the writers. That is when unfairness happens. So unfairness happens in a social context. And let me tell you something about bias and fairness, the very complex relationship. People talk about bias and they solve it with fairness, when exactly that is not the case. And that's basically why we're still struggling from a technical perspective to find a solution for the bias problem. So you put it in a social context and you get unfairness. Fairness is something that's undefined, actually, and it is something that we want it to be that way. Because once you define fairness, you're basically defining it for certain social norms. And no society is similar to the other. So what is fair for us in North America is not necessarily fair for people in Japan. And they need to define their own fairness criteria. So it has multiple notions, and that's exactly how we want it to be. And once we turn that bias fairness into laws, that's when we have discrimination. So discrimination is where you have a bias and then you have the fairness component to it, so the social component to it, and then you put it into laws. The governments turn it into bills and stuff. So that's where discrimination happens. So it is governed by law, and it is concerning groups. So it's based on your membership to certain ethnicity or color or ability levels. So that's the definition of bias in trying to simplify it as much as possible. Now, how does it happen? If we want to talk about if we go back to the whole AI system idea, now how does it happen? There are three components to an AI system. As we discussed, there's the data, there is the processing and the output, and there is the human. So these are the three components of an AI system. First, the data. Garbage in, garbage out. What I want also to hear in the chat, where is data collected in BC Transit tools? Internet is English biased. That is very true. Okay, I want to hear from you on BC Transit Tools. Where do you collect data, or what data do you collect, or yeah. Excel, Hubble, GDE, surveys, physical bus systems, bus on-time performance, from the website, cart, surveys, employee engagement, depends on the application, our HR systems. Yes, yes. So I want you, as you're collecting this data in person, that's the one that I can relate to as a writer. I think it's mostly about me getting on the bus, like the Yumu app that I'm using. Every time I scan that barcode, I'm like, I wonder if they know that I didn't go out this week, except for once. Or it's more of like, oh, they never asked me about my age. They never asked me about, I wonder what data they keep on me in the file. So actually, for that, like, that could be, like, whoever said in person, that is the the main gateway for you to collect data is like through the bus. As a bus driver, I'm not sure if we have bus operators here today, but you're also like the main data collector because you see all of the people who are getting on certain lines. So think of UVic lines, like the number 4 that's going to UVic, and I'm here talking about Victoria people. You will see differently than people who go on the 95. So it's really like where you get the data. Now, this customer service agents, yes. That is a really good. So yeah, we're talking about data, garbage in, garbage out. That's what people know, or like that's what almost all of the people know, that garbage in, garbage out. However, there is more. It's not only the data. Next comes the outputs, or like the processing and the outputs itself. So as we were explaining the processing part about the system, I did explain how it tries to learn by getting exposed to more than one example. And the more similar the examples are, the better it learns. So it is something that is biased by design. The whole idea that you learn from examples is a biased process. And if you go back to the very first papers of how systems are built, you can, like, there's a paper from the 84 where it says like bias is needed for learning, like the need for bias of bias for learning. So it is something that we don't actually want to remove. If we remove, we get systems that does not learn and that are useless. So it is biased by design towards the average person, because that is the person that we have the most data points that are similar to their features, or like average behaviors in a community. Okay, so that is the second part, and this is how bias can happen. Now, the third part is the human. And this is the most interesting piece in our puzzle with all of our cognitive biases. Speaking of which, let's look at that. We have cognitive biases codex here, where we can look at different biases that happen consciously or subconsciously, and we use in our daily interactions, whether with people or in our focus today with systems as well. So whatever we feed back into the system is actually contaminated with all of our cognitive biases, and contaminated with the idea that I love chocolate ice cream, and then I want everybody to also love chocolate ice cream. I want you to see if there is something that you can spot here where you can think of cognitive bias as something that you feed back into the system, or something that actually you think this is an entry point for an AI system that you are working with, and it is impacting you from one of these entry points. To make it easier for you, just focus on this outer circle and give me examples. Recency bias. Confirmation bias. Okay, what is the outer dot that talks about confirmation bias? I can't really find it. But I definitely think this is, oh yeah, confirmation bias.
2 o'clock there, it's we're drawn to details that confirm our own existing beliefs.
Yes, exactly. So basically, when we get a response from ChatGPT or any kind of system, and we kind of wanted to hear that, we tend to make decisions that are more in line with what we want to hear. If I would not have believed it, I would not have seen it. Yes. Yeah, that is very right. Okay, now we're going on to system biases. Now, this is just for you to look at. It's also not something that we will be discussing in details, but because this is too technical, like there's a lot of technical stuff that go behind it. These are like 27 bias types that the literature has agreed on. It's definitely not the only ones that AI systems have. There's much more. But unfortunately, the field is still very infant. So these are only 3 main resources have focused on that. Today, I will be mentioning a few bias types, like these are the ones at the bottom here, like funding bias, historical bias, representation bias, inherited bias, throughout the talk. But I'm happy to answer any questions you have on any of the other bias types here too. All right. Now we're going to the third part, interacting with bias systems. Let's get started. There is you and a system. It is bidirectional. We learn from it and it learns from us. So basically, because like we learn from whatever decisions it is giving us, and that is basically the power that it is giving us. It is empowering us with new learning resources, regardless of its accuracy. However, whatever it's outputting to us is either enhancing our decisions, making us doubt our decisions, or making us change our decisions. So we are learning from it. And then the system as well is learning from us. So whatever data we feed into it, it updates the system and it learns again. And this actually gives us, opens the portal to malicious prompt that people would be sending into the machines, or some kind of manipulation. But these are like, there are guardrails around that, so it's not directly. However, there's like a whole position called prompt engineers. So prompts are really strong, and so yeah, the systems also learn from us. It's not only like, it's a two-way thing. It's not just one directional where we're only consuming these outputs. Okay, so it's bidirectional. And then if we use the biological neural learning approach with these systems and leave out reasoning. So if we're talking about using our biological approaches, if we're talking that there's only like 2 approaches to intelligence for a human being, which is not true. But if we use only biological approaches where we're like, whatever experiences we're getting out of this system, we're going to learn from it. And we're not going to use any kind of reasoning. So that's the first if. The second if is, if the AI system outputs are biased against us. So think of a system that is trying to promote vanilla ice cream for you. It can be as simple as that, or as big as like really being biased against you in the real sense. But that is also biased against part of your identity, which is what you like. Then we're feeding it our cognitive biases, and it is feeding us our its biased decisions and outputs. If the interface didn't have the options that represent you, like the poll that I sent earlier. So basically in the poll, in the first question, I intentionally didn't add all of the options. I didn't add another option as well. And if you had other use other than work, because I think that was the most voted for option, then you will be left out, basically. So the way the systems decide to present their information to you can cause you to be left out. And that is actually called presentation bias in technical terms. And basically, like, I added school there as well. I'm not sure if you have students who are interns working there, but basically I didn't expect a lot of students. So I kind of didn't make a very thoughtful choice for who to represent and who to leave out. So that can cause harm. So you will be left out. Because we think it's usually true, we internalize a belief that we need to produce decisions similar to those of an AI system. I've met people who are like tremendously creative, who are awesome, who do stuff in a very brilliant way, and then suddenly they ask me, as soon as they know that I do consultations on responsible AI, they're like, oh, what do you think about ChatGPT? The last time I used it for my work in this way, and then it gave me these answers, and it's really smart. And then I started to change my methodology. And I'm like, yes, you are pretty smart and pretty creative. But it is something that we tend to do, is that we want to produce decisions similar to those of an AI system. So that is another symptom for when we interact with these systems. Because we think it is smart, we trust it, but we doubt ourselves. And that is something that slowly could diminish our identity and who we truly want to be, and then giving it all the control to the system because we think it is smart. Since AI decisions are based on Sam's characteristics, we all want to become Sam at the end. That's really where we start losing our identity, because we think, okay, so the systems are giving us all of these ideal answers based on an ideal characteristic that is a mix of all of the top characteristics of everyone, or like the average characteristics of everyone out there. So we unintentionally start feeling that we want to become like Sam. Now let's add some complexity to interacting with these systems. So there is you as the user or the human who is interacting with the system, and remember there is a human in that system as well. So now I just remove the human out for you as a user, but there is still the funder who is giving all their funding bias into the system. There's the regulator, there is the designer. In the system as well. And then you add that this is a third-party tool. So you are not working with the system directly, you're working with an embedded tool inside another system. So you're talking about two systems interacting with each other. And if one is biased, then the next is going to inherit that bias. And that is called inherited bias or error propagation, where you're learning, where one system is learning the bias from another system, and then it is feeding it into your biological system. Let's add another complexity there, which is providing a service to your community or making decisions for the company. So basically, that is you as an individual, and then when we put it with a group of people, you're basically learning from them. They're learning from your decisions or getting impacted by your decisions. And in BC Transit's case, you're literally connecting communities. So it's much wider reach. And then you can see that this is like a huge web of people interacting with each others and systems interacting with each others, and then the humans and the systems are interacting, which causes the bias to be a very complex problem. And that's actually why it's been a very long time for us trying to resolve the bias problem, and we're still not quite there. Now, what do we do to break out of this cycle? We want to bring the reasoning back to make these informed decisions. So basically, so far, we were talking about just getting to interact with these systems without reasoning about these decisions that we're getting. And basically, we want to get that reasoning. Now, but our reasoning could be biased, right? I know that you might be asking that question. So we will get to that in the next section, where we can talk about what we can do to stop this cycle and manage bias. Now, to do that, we are going to create word clouds. I want you to think, what values do you believe in? And then what values that you want to see in your community? Kindness, integrity, equity, truth, integrity, again, respect, accessibility, reliability, authenticity, fairness, compassion, accountability, transparency, creativity, inclusion, teamwork, and honesty. I love that. And then what values do you want to see in your community that you want to live in with these systems? Respect, inclusion, fairness, transparency, accountability, teamwork, solidarity, accessibility, kindness, equity, mutual respect, compassion, and authenticity. You guys know the values that you want, and I love that. Okay, all right. That is very good because we're not getting any new answers, right? Yeah, I guess so. So that is very good because what we want to do now is to use these values to change the narrative, to basically decide how we want to interact with these systems, and to set that these values to be our standard that I mentioned at the beginning, that bias is an inclination or a deviation from a standard. So we want to set these values as our core to whatever action we want to take. So next section is the action framework, what we can do to manage bias and make informed decisions. This is a framework that me and two of my colleagues have spent about 4 years trying to come up with after we figured out that bias is wanted and unwanted. And the whole bias problem is not something that we want to eliminate, but rather it is something that we want to mitigate and manage so that we can get the benefits of it, and at the same time to get the harms that it can cause away from the road. This framework is designed for researchers and for those of you with a tech background on how to build a system and how to deploy a system. But also for today's purposes, I noticed that I wanted to share with you this framework because we can simply follow the same steps for whoever researcher or builder is using to manage bias in their systems. We can actually use that for our own biases and interacting with these systems as well. So we can mirror the process. So first step in this framework is to understand the sources of bias. So understand the sources of the different bias types and foresee the possible bias types for the system or the systems that you're interacting with, or also the decisions that you're trying to make. And this is what we have been doing throughout the first 2 sections of this talk, where we worked on understanding AI systems and how bias happens and where are the entry points for each of the 3 components of an AI system. So these are the sources. Now, if you look at the evaluation and mitigation, this is something of a continuous state. So think of this as okay, so you want to evaluate if, or you want to check if the system that you're using is producing bias or not. So you evaluate it, you find bias, so you go and mitigate it. When you mitigate bias, you can actually create new bias. So when you try to take an action to remove that bias, that can cause new problems. So you want to reevaluate it. That's one case. Another case is when it's you did an evaluation mitigation and then time went by, you need to reevaluate and remitigate. So it is something that we need to be doing on a continuous stage where we evaluate the system if the biases that we were foreseeing have happened or not, and then we want to take an action to mitigate this bias. So this is the framework that you need to follow. The first part we already took care of. Now let's look at evaluation. Now, to evaluate a system, you would want a setup thing. Now, I noticed that there's people based on the responses for what you use AI for from different departments, and I was expecting that because it's not easy to talk about evaluating a certain problem for a specific department in such a session where we have multiple departments. So what we have is a setup where or a general process that you can identify to your own department, your own goals, your own tasks. Setup is simple. You identify your values, and this is something that we have started with already. And then you want to question the tool. You need to come up with a list of questions and then ask about this tool. And then you want to compare these answers to your values and then decide, is this something that aligns with my values or not based on these answers, or do I need to look for another tool, or whatever decision you want to make. Example of this process. So first you identify your values, question the tool, and compare the answers to your values. Questions: ask the provider for system information. So if you're using a tool, you can simply send them an email and ask them for information such as data that they use to train the model or to test the model, or or is it training continuously or not, and on which data is your data being taken to retrain the model or not. Just any question you want to ask about the data. Explainability. Can they provide you with an explainable explanation for why the system provides certain outputs or not? Probably not, because most of the AI systems right now are neural and it's black box nature. And then we have human involvement. Like, you can ask about the human in the loop for their systems. What did they do, and how are they incorporating human intelligence into whatever system they are building? And then, so this is like mainly questions to the provider. Try to frame your questions on the 3 different parts of an AI system. So questions about the data, questions about the processing and the outputs, and questions about the human that is building the system, or also like you can ask about the other users of the system. And then there are questions that you can ask yourself: why I should trust this tool? Is there enough public information on this tool or not? Is it transparent enough so that I can know how it works? Does the output make sense or not? And be careful, there could be some of your cognitive biases going there too, which we will get to how to eliminate that in a second. Would this output cause harm to other people? Is it saying what I want to hear? And that's going back to the confirmation bias that we were talking about earlier. If I would not have believed it, I would not have seen it. So you can always ask yourself other questions that you can conclude from that cognitive bias diagram. So that's what the other is there for, because this is not an exhaustive list for all of the questions that you want to ask the tool. And perhaps you can do this as like an exercise in your department of like, okay, these are the questions that I really care about any tool that we're using for our own goals and for our own values. So remember, the basis for any answer that you get out of these questions is to ask, does it align with my values or not? Does it align with the values I want to see in the community that I'm creating at BC Transit or not, whether internally or also externally with the writers that you get to serve? And basically, so I mentioned that you can sit internally with your team to try to come up with more questions. This setup is actually the first step towards creating like frameworks for your own departments, policies, or also like creating a roadmap for where you are right now with AI and where you want to be. Remember, the core are the values and the human that you are serving and that you are as a human. Okay, to bring reasoning back, always remember. Okay, now there are 3 conclusions, or like 2 conclusions that I want to remind you of. That these results that you get out of a generative AI product or any kind of technology or form of AI that you're using, these results represent what the majority of people think, because this is coming from the data of the majority of people. This is a collection of other people's opinions. So data can be opinions, can be acts, can be thoughts. It's not necessarily the right answer. So before you get any kind of answer from the system, you should remind yourself that these systems are not logically inspired by design. So they're basically telling you what the majority of people think. And try to add a sentence before you get any answer. I think, like, the system is telling you, I think this is what the majority of people think. And then take the answer. It's not something that you take as like, okay, this is the right answer. Exactly what the system is really smart, and I just need to follow the answer that it gives. So this is something that you keep in mind, and that way you activate your reasoning and you're back in control, not the tool actually. So this is, in a nutshell, how to evaluate as a user of the system. There's a lot of work that still needs to happen in your own departments, but for you as a person, because today our focus is on the individual as the main block to breaking out of this cycle of bias, I want you to always activate your reasoning and identify your values, question the tools, and compare these answers to the values that you've identified. Now, to mitigate again, we're not eliminating bias because bias is not something that we want to eliminate from these systems. Other than that, we'll just go back to square one where we don't really have systems that work. Set up for mitigation, there are two approaches to how you mitigate. It's proactive and reactive. So there are actions that you can actually take before you go on with using the system. And before bias could actually happen, so you can imagine what bias could happen in the future, and then you try to put in some guardrails to prevent that from happening. And then there's the reactive actions where you've already used the tools, you've already noticed there is bias, and then what do you want really to do about that? So in terms of guardrails, these are also examples. As I said, like you can come up with your own examples for your own values and then, or for your own department as well, departmental values. So examples for guardrails, based on your values, diversify your input. Use more than one system, get more than one opinion, and that actually could just help you also get over your own cognitive biases of like judging a system's output, because there's something also called complacency bias where you just like agree with the system. So that is something that you want to remove by getting more than one opinion or using more than one system and comparing these results. Different guardrails you can identify there. Now for the reactive part, you can make changes to your decisions. So basically you made a biased decision, you didn't know about that. After you evaluated, you found that your decision was biased, so you want to make changes to this decision. Or maybe you want to choose another tool. Like that's also something that that could be an example for an action type. Things to remember, and this is something that I really want you to make before you go into using an AI tool. You are choosing to solve a problem with an AI tool, which in turn causes new problems to emerge. So that is something why we said that it is a continuous state. Your goal in the first place was to solve a problem, not to use AI. Okay? So focus on solving the problem, not that you want to solve the problem with AI tools. And that will change the whole approach that you take. And then that will also put you in control, not the tool with its own biases. Okay. What else? A few final thoughts before we move to our final exercise is what else is happening now? I know that, or I don't know, for me, when I started with this, it was very daunting. I was like, oh my gosh, there's not enough research. People are still not doing a lot in that area. I know that people are aware of the problem and a lot of people want it to be resolved, but really there isn't a lot being done. So it was overwhelming at the beginning. However, I want you to know that there is you're not alone. There are people who are developing standards. There are regulations that countries are trying to do. So there are standards on like how to build a system in an unbiased way, and that is a standard that I assisted in developing with IEEE. So basically, we were talking about, okay, so these are the standard practices that you take. So you eliminate bias, and there are like the whole like standards families that you get to read on different issues. So with AI, we don't only have bias as a problem. We also have climate change actually is an emerging problem. We have privacy, we have human well-being, and multiple other issues that we want to take care of. So there are standards on how to build systems that are free from these issues, or like with these issues managed really. And regulations, I think the one that is like there are multiple countries that are trying to regulate how AI systems are being built and used. In Canada, we had IDA before the beginning of this year, but as the new government formed, the new parliamentary session. Now we don't have anything on paper, and we are still waiting for new regulations or like a new bill to be proposed on how do we want to regulate AI. So I think that is a great opportunity. If you want to have a say there, contact your MP, contact your MLA. Also on a BC level, we have guidelines, but do talk to them about what you want for these regulations and standards and general frameworks or guidelines to look like, so that it can foster your values. And now I hope that by the end of this talk that we have a new narrative. A few conclusions. I want you to remember that the focus is you. In whatever system you're dealing with, it's not the tool, it's you. It's your values, and it is what you want for this value to do. And what community you want to build with that tool. It's not about the tool. And that is what we want to finish the talk with. But before we do that, we still have Sam. Sam is still thinking. It is 2025, and his imagination that you sent wasn't really the reality in 2025. So now it's 2025, and he's thinking about 2030. And that is a year where a lot of people think it's either like the AI bubble is going to blow, or we're going to have artificial general intelligence. So it's like kind of 2030 or 2035, but let's say 2030 because he will be 83 years old at that time. It is the future. I want you now to imagine on the whiteboard, what do you think that he wants the future to look like after he had all of these imaginations about robots, wars topping, etc. And then the reality that he's living right now, and then what he probably wants for the future to look like, or like his kids, what kind of future he wants his kids and grandkids to live in. I think Sam is very creative with what he wants for the future. He's not afraid, which is really cool, because the whole purpose of AI is to make the impossible possible. So we do want to embrace it. Whatever problems we have around AI is something that we need to resolve. AI as a tool is something that we need to use in our daily life, not something that we want to be angry with or try to figure out like how to stop it. So I really love the diverse opinions that I see here, where people are optimistic about the future. They want new uses. And there are people who are like, yes, I love where we are right now. I just want it to be better.